Hello my dear students, let me check, give me a minute, let me check if stream is working or not. Okay, let me check once if stream is working or not. Yes, so the stream is working. Hello, good morning. So today I am going to discuss, even though 50 questions are mentioned, we are going to discuss more than 50 questions, don't worry about it. And all the questions that are going to be discussed in today's session are again very important. We have already done 3 sessions, one session of 100 questions, one session of 60 plus questions yesterday, and another 50 plus questions in today's session. Okay, and if you are following our lecture, definitely you are basically what we are trying to learn through these sessions are basically how to tackle different varieties of questions, and in between also we are learning some concepts to how to approach a question, which is very important for all of you. Good morning Distortion, good morning. So if I see anyone today asking about anything, what you have eaten, where are you from, I will start blocking people. Okay, so if you are in the class, listen to the class, or you stay quiet. Okay, if you are asking whatever your daily routines, you can ask them after the class. Okay, so now let's start with today's session. So first of all, I want to remind you that the important chapters that you must study, at least revise before exams, that is electric charges and field, electrostatic potential, capacitance, current, electricity, moving charges and magnetism, alternating current, ray optics, optical instrument, wave optics, and dual nature of radiation and matter. Now you might ask me, sir, how can I revise? There are not much time, one day time is left, and so many chapters you are suggesting. You just need to go through 2 things. Okay, there are 2 things that you need to do apart from solving questions, obviously, that you are doing in this session. You need to go through the NCERT summary, and second is points to ponder. I hope you have already gone through this in once or twice, but again, to revise quickly, these are the 2 things, and there is a formula and dedicated formula, and dimension chart is given just before the summary. You can go through that as well. So these are the main things that you have to look just before exam, in the evening or in the afternoon, whenever you get time. That will boost your preparation, and that will actually complete your preparation. Okay, so let's start. A series LCR circuit contains inductance 5 millihenry, capacitance 2 microfarad, and resistance 10 ohm. If a frequency AC source is varied, what is the frequency at which maximum power is dissipated? Very common question. So in yesterday's lecture we have not solved too many alternating current questions, so that's why we have included all the different varieties of chapters today. So basically, what is the meaning of maximum power? Maximum power refers to resonance. So basically, you have to find the frequency of resonance. Okay, nothing else. So resonance frequency you have to find. The capacitance value is given, the inductance value is given. We know that resonance frequency is 1 by 2 pi square root of L into C. Very simple formula, one straightforward formula. So 2 pi square root of 5 into 10 to the power of minus 3 into 2 into 10 to the power of minus 6. Okay, so that will be 1 by 2 pi square root of 5 to the 10 into 10 to the power of minus 9. Right, 5 to the 10, 10 to the power of minus 9. So 10 into 10 to the power of minus 9 will give you 10 into 10 to the power of minus 9 will give you 10 to the power of minus 8. Okay, so 10 to the power of 8 square root will give you 10 to the power of minus 4. So it will be 10 to the power of 4 by 2 pi. Okay, now if you see that none of the option is matching. Why the options are not matching? Because you have to take 110 out, okay, then write it like this, and 10 to the power of 3. Now you see that this option is matching because 2 5s are 10. Okay, so sometimes the direct, in some cases you will get this exactly as the answer given. Sometimes you have to simplify a little bit to get your answer. Okay, but after solving this much, you should be able to find the answer even if you are not getting it at the first go. So that is very, very important. Sometimes even after solving the problem correctly, you may not find the exact solution. You need to reduce it further, simplify it further. Yes. Not option A, but option C is the correct answer. Yes, Gautam is correct, Amog is correct. Okay, yes, C. See, those students who are discussing in the chat, they are not from either from the state, or they are basically from other stream. They have found this chat and they think that okay, we will go there, we will chat, we will disturb sir. That is the main purpose of the students, those who are chatting unnecessarily in the chat. Okay, so if you are listening to the class, ask doubt and answer the question. That's it. But otherwise, the students who are asking unnecessary questions, ignore them. If you are a KCET student, ignore those students. Okay, ignore the noise. That is also important for you. That is a good lesson for you. Okay, ignore the noise. You have to focus on the class right now, because tomorrow is your exam, not even day after tomorrow. Tomorrow is your exam. A step down transformer has 50 turns on secondary and 1000 turns on the primary winding. If a transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? So here input voltage, input current is given. 50 turns on secondary, 1000 turns on primary. So you have to remember, very important thing is that voltage in primary by voltage in secondary equals to number of turns in primary divided by number of turns in secondary. In terms of current, so voltage primary, number of turns primary, voltage secondary, number of turns secondary. But in terms of current, the order reverses. So it will be current in secondary divided by current in primary. So here the order is inversed. Okay, just remember this small thing, then all transformer related problems, if they ask you this kind of problem, you should be able to solve. One more thing, that input current into input voltage should be output current into output voltage. So these are the main things. I have not seen any efficiency based question in in KCET. COMEDK it comes, but in KCET I have not seen any efficiency based question, but that should also be tackled if you know this formula. Okay, now let's find out. Primary turns is 1000, secondary turns is 50. Okay, secondary current we are trying to find. Primary current is given as 1 ampere. Okay, so it will be secondary current is 20 ampere. Okay, secondary current is 20 ampere. So option D is correct answer. Paper attempt strategy, Harsha Pranav is saying. Harsha Pranav, let me complete the class. At the end of the class, I will give you 5 very important paper attempt strategy. I have already given you the revision strategy. Now I will give you paper attempt strategy also, but not now. Let me complete the class first. Okay. In the given circuit, the resonant frequency is, so here a LC circuit is given and they asking you what is the resonant frequency. Don't worry, after looking at the values, okay, you will be able to solve it. So 0.5 millihenry and 20 microfarad is given. So direct question, direct answer. They are not masking this question in anything else. So just use the formula and calculate. Okay, 1 by 2 pi. Now in the exam, if you remember the formula, do not write the formula while because writing the formula is actually waste of time. So directly write the values inside the formula. Okay, directly write the values inside the formula. Okay, so that is very important. Because why I am writing, because obviously I am trying to explain it to you so that you remember, but in the exam hall try to avoid that unless and until you think that the formula requires to be in the written form. Otherwise do not write the formula, directly write the values inside the formula. Okay, so basically instead of writing this, you should start with this. Okay, 20 microfarad means 10 to the power of minus 6. Okay, so again 20 into 0.5 is 10, 10 and 10 to the power of minus 9 into 10 is 10 to the power of minus 8. Minus 8 square root is 10 to the power of minus 4. Okay, so 10 to the power of minus 4. So basically it will be 10 to the power of 4 by 2 pi. Now, as I mentioned, the exact the answer is given in a different order. So you can do two things. First of all, you can write this as 10 by 6 into 1000. What we have done, we have basically written 2 pi. In the exam, if pi value you have to apply and data is not given such a way that if you cannot take the pi value as 3.14, then always take pi as 3. Okay, but some cases they will give you a value such that suppose 6.28. Okay, and that is coming by divided by pi, or 628 divided by pi. So in such cases you can take pi as 3.14. Otherwise, for quick calculation, always use pi equals to 3. That will give you a very close correct answer. So here you get 1 and 4. 4 means 6. 1 6. So it will be 16000. So you get the answer. Sorry, not 1.6. My mistake. 1.6. So you get 1600. Okay, so 1600. Approximately 1600 is should be your answer. So 1600 means correct answer is this one. Okay, so 1600 is this one. So you get the idea. So basically what we have done, we have taken the value which is very close to pi and we have cancelled it and we found the closest value, and from there you calculate. You do not need to find the exact value. No one giving you extra point for finding exact 1592. So calculations can be tricky if you are not aware how to deal with difficult calculations. So that is one very, very important point. No one is going to give you points for finding exactly 1592. Okay, but if you because you have to solve it and then find the correct answer, you realize 1600 cannot be any other value other than 1592. Right? So that's how you should tackle difficult calculation based questions. That there will be some questions, not all questions. Many questions you can directly cancel out and you will get a good answer, but many cases you have to take a shortcut route. In the given circuit, the peak voltages across C, L and R are 30, 110 and 60 volts. So all the voltages are given across these three components. And 60 volt respectively. The RMS value of the applied voltage. You have to find the RMS value of the RMS voltage. Peak values are given. So peak values are given means you can calculate the peak value of the input voltage as well, input source. How to do that? Input voltage peak is given by square root of VR square plus VL minus VC whole square. Same as impedance formula, but in impedance we calculate resistance, total resistance of the circuit. Here we calculate the total voltage of the circuit in terms of voltage. Okay, so now what is VR? VR is given here as 60 volts. So 60 square plus L is 110 and VC is 30. Okay, so 110 minus 30 is 80. Now if you remember, 6 square plus 8 square is actually 64 plus 36, which is 100, and square root of that is 10. So basically 60 square plus 100 square will give you 10 into this zeros. Okay, that is basically that is nothing but 100. So 6 square plus 8 square gives you 10, 60 square plus 80 square will give you 100. Okay, so V0 is 100 volts. So definitely this is peak value. This you should not mark 100 after that. You have to find the RMS value. RMS value is peak voltage divided by root 2. RMS value is peak voltage divided by root 2. So the answer should be less than 100. Answer should be less than 100. And if you see the options, only one option which is given less than 100. So you don't need to do any other mathematics further from here. You can divide 100 by 1.4 and calculate 70.7 and waste your 1 minute of time. Or after reaching here, you realize the voltage should be less than 100 because they are asking you RMS, and in the question it is given peak voltage. So the trick of the question is peak voltages are given and they ask you RMS voltage. If peak voltages are given, you can calculate peak voltage using the formula. You cannot directly calculate the RMS voltage. So if you are marking 100 volt, you are losing marks. Okay, so be careful. There will be traps like this. Very easy question, but there will be trap like this. If you are not careful, you might fall for the trap. Sir, please tell which are the experiment questions from P1 and P2 really geo-verse. If I know, then police will come and arrest me. If I had knew which experiments you have in your, according to your syllabus, 12 experiments in P1 and 12 experiments from P2. So total 24 experiments. Out of that, 3 questions will come. Okay, it can be basic measurement based questions. We solved some of them yesterday, or it can be directly in-depth question from that, directly from the experiment. Okay, no one knows. Okay, if someone says I know, then police will come and arrest him. If that is true, of course, that means he has done the paper leak. So that is not possible. 24 experiments are there. I cannot say which are, but I can say important experiments. For example, your pendulum experiment is one of the important experiment. Then last year there was glass slab experiment where you are doing the refractive index. So that one is important experiment. Then semiconductor diode one is a important experiment where you find the diode resistance. So that is, those are the important resistance. But exactly what will come, that only known by the paper setter who set the paper. Okay, there are 24 experiments, no matter from wherever they can take the experiments and give you. Okay, so there is no such thing that I know the experiments which are going to come. If someone is saying, as I said, either they are lying or they have done the paper leak, and if they have done the paper leak, then police will come and arrest them. Which of the following represents, just joking, okay, don't take it seriously. Which of the following represents the variation of inductive reactance? But I did solve some experiment based questions yesterday's lecture, so you can go and check that out if you want. Which of the following represents the variation of inductive reactance XL with the frequency of voltage source nu or F? Okay, we know that voltage frequency and XL, what is XL? XL is equal to 2 pi F into L. Okay, so if you increase the frequency, you can see that XL is directly proportional to the frequency F. So instead of nu, don't confuse, nu and F are same. Okay, so XL is directly proportional to frequency F. So if you are increasing the nu, XL should also increase. So correct answer is A. This is a straight line graph. Okay, always remember Y is equal to mx plus c. If this kind of equation you are getting, then it should be a straight line graph, and here c is 0. So there is no constant over here, so that means c is 0. So basically it's a straight line graph passing through origin. Y is equal to mx means passing through origin. Y is equal to any other value means passing through a constant section. If the same question is asked about xc, xc is 1 by 2 pi f c. Okay, now if you keep c constant, if you only change f, then what happens? The graph of xc versus c is inversely proportional, so it will be like this. So this is xc versus frequency. Okay, xc versus frequency is a pattern like this, but xl versus frequency is pattern this. Okay, so don't randomly answer this one, even though I say that this is one of the most common pattern. There are some exceptions where they might ask you a question which is not this pattern. Okay, and if you really want to prepare for COMEDK exam, because right now you are all occupied for your KCET preparations, and after your KCET exam, if you really want to attempt COMEDK, then don't worry, we are bringing you a 10-day crash course which will be done completely online. and in English. So the batch price is 1499. There will be 10 days very extensive lectures, okay, live lectures will be there, question solutions, questions asking doubt classes, everything will be covered in this session. So don't worry if you have not started preparing for COMEDK, because we will make sure that you are exam ready for COMEDK. Okay, already you are studying for KCET means you already have some level of preparation, but COMEDK is different than KCET. So if you are thinking by only preparing for KCET COMEDK I will crack, that is not possible. For that you have to prepare for COMEDK. Now if you want to do it solo, that is fine, but if you want some help, then definitely this COMEDK 10 crash course is very helpful for all of you. So do consider it after your exam, not now. Classes will start from 27th of April. Okay, so do it before 27th of April. A 100 watt bulb is connected to an AC source of 220 volt 50 hertz. Okay, then the current flowing through the bulb is, so what is the current that is being flown through the bulb? Okay, AC source of 220 volt 50 hertz is the source. The wattage of the bulb is 11 watt. Okay, we know that power rating is given by voltage into I. Okay, now here they have not mentioned which current, peak current or RMS current. So peak current and RMS current, because it is not mentioned, basically this is RMS voltage, so we will calculate RMS current only. So current is basically given by P by V. Okay, power is 100 watt and voltage is 220. 0 cancels, 5 by 11. Very simple. Okay, so don't be confused because it is given as AC. Okay, so same law of Ohm is applicable to AC as well. Okay, so bulb will act normally as it is acting in a DC circuit. So you can still apply P is equal to VI and you can calculate I. Okay. How much you can score, that depends on how many of the questions you answer. Okay, distortion is correct. Which one, Srinivas? How to understand that the connection is to be taken as resonance without mentioning it in the question? Please help. Question 1, how to understand? So question 1, if it is mentioned that maximum power drawn, if you see the questions like when will be the maximum power drawn, when the current will be maximum. So if you read this term maximum in AC circuit, if you see anything such as maximum, that refers to resonance. Okay, maximum refer to resonance. All maximum happens at resonance. Okay, maximum current, maximum power dissipated, okay, maximum voltage drop across the resistor, everything happens at resonance. Okay, so if you see a AC circuit based question where maximum is mentioned, it should be a resonance based question. Okay, so if you see as a AC circuit problem where maximum is mentioned, then you should always get it that this is the resonance. Okay, that's it. So don't be confused if you just read that maximum term, that maximum refers to resonance in AC circuit. Okay. In an LCR circuit, the potential drop across L, C and R are respectively given. Then the source voltage is very simple, easy question. Okay, we have solved one such question. So V equals to so again here nothing is mentioned. Nothing mentioned means directly only thing that we need to do, VR square plus VL square, not VL square, sorry, VR square minus VL minus VC whole square. Okay, so VR square is LC and R. LC and R. So R is 60 square plus 120 minus 40. So that will be 100. Okay, so again 80 square plus 60 square, so 100 volt. So 100 volt is the answer. Now here do not divide it by root 2 or multiply by root 2 because that is not mentioned. So you just find the voltage, that should be directly the answer. Okay, sometimes they will give you easy questions like this. The average power dissipated in a pure inductor. Average power dissipated in a pure inductor, average power dissipated in a pure capacitor is always 0. Okay, always 0. They do not consume power. Okay. A long solenoid has 500 turns. When a current of 2 ampere is passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 to the power of minus 3 Weber. Then the self-induction of the solenoid is. So a long solenoid has 500 turns. When a current of 2 ampere is passes through the resulting magnetic flux. Okay, so now what formula we have to use, and the flux linked is given. Flux linked is given. So flux linked means total flux should be n into individual flux. Okay, this is for one turn, and how many turns are there? 500 turns. So total flux is basically 500 into 4 into 10 to the power of minus 3. Okay, now you remember one very simple fact, that induced EMF is given by d phi by dt, right? From Faraday's and Lenz's law, there is a negative sign. Ignoring the negative sign, it is d phi by dt. And again, in terms of inductance, the same EMF can be written as L di by dt. Okay, so if you compare these two equations, you can write phi is equal to actually L into I. Taking integration, etc., you can write phi equals to L into I. So that is a very simple formula. Sometimes we forget, but that can be very, very handy. So phi is given here 500 into 4 into 10 to the power of minus 3. L we are trying to find, and I is given 2 ampere. So let's directly divide it. So it will be 2 into 500 is 1000. 1000 in 10 to the power of minus 3 is 1. So it will be 1 Henry. The answer will be 1 Henry. Just give me a second. Okay. Right, so either you start from this formula. If you forget, you can memorize, you can recall this equation, and you figure out, okay, 5 should be equals to Li. Now recalling this might take 10 seconds extra, but if you remember this, you can save some 10 seconds. Otherwise, this is a very easy question. And KCET exams, as I mentioned, you should not overthink or overdo a question which is easy, should be solved quickly. A jet plane having wingspan of 25 meter is traveling horizontally towards east with a speed of 3600 km per hour. Given vertical component of Earth's magnetic field BV equals to 2 into 10 to the power of minus 4 Tesla, then the potential difference between the end of the wing. So a plane is flying, okay, and the wingspan is given here 25 meter. The speed of the plane is 3600 km per hour. So meter per second, 5 by 18. Kilometer per hour to meter per second, 5 by 18. So it will be 200. 200 into 5 is 1000. 1000 meter per second. Always convert kilometer per hour into meter per second. So speed is calculated. Now what is induced EMF? Induced EMF is BVL. Okay, so B is 2 into 10 to the power of minus 4. V is 1000, that is 10 to the power of 3. L is 25. So you can say 25 into 2 is 50. 50 into 10 to the power of minus 1, that is 5 volt. So the induced EMF is 5 volt. Okay, so very simple, easy problem. This kind of questions are very common in KCET. So if you see this kind of questions, don't hesitate, solve it quickly and move forward. A wheel with n number of spokes, each of length L meter, is rotated with a uniform angular velocity omega in a plane normal to the magnetic field B. The EMF induced between the axle and the rim of the wheel. So here we have a rim which is rotating in a magnetic field which is passing through this normally, okay, and there is a rim. Now when a rim is rotating, angular frequency is given. Okay, now induced EMF is given by, because of motion, induced EMF is given by BVL. Okay, now L of the rim, of the length of the rim is constant. Okay, magnetic field is constant. What about V? So if you can find this V, you can find the total induced EMF as well. Now assuming that entire rim is conducting, you have to multiply with the factor n. Okay, you have to because there are n number of spokes, so each spoke will have the same induced EMF. Okay, so you have to multiply with n to finalize the value. So let us move and check what is the induced EMF for a single rod. So omega is constant for a rod, but what about linear velocity? So if you see that linear velocity is given by r omega. R is the distance from the center. Now distance from the center is not constant, so for a point exactly located at the center of the rim, velocity is 0. A point located exactly at the opposite side of the rim, it is basically V is equal to omega L. Right, now you can do the integration method, but there is a shortcut method. The shortcut method is that you basically find the average speed. Average speed is the velocity at the center and velocity at the extreme edge, which is 0 plus omega L divided by 2, that is omega L by 2. So this is a shortcut method. Now some of you can remember it as a formula as well. So now as I mentioned, you have to multiply n, then b, then v is omega L by 2 into L. So it will be half n b omega L square. So correct answer is half n omega b L square. Okay. Mahantesh, no, this is not enough. This is just a what we are doing, we are revising, we are helping you to revise the concepts, helping you to boost your confidence, because if you are able to solve these questions, you will definitely be able to solve the questions in the exam. So if you think only studying this means what? Are you solving the questions? You are posting your queries and doubts. Please listen to the lecture first. Try to solve the questions, then you will realize yourself that how many questions I will be able to answer. Are you able to solve these questions on your own? If you are, then very good. But if you think that okay, I will download the PDF and I will memorize all the questions and answers, no. Okay, if you understand the process, yes, how to solve a question, how to tackle a question, how to approach a question, those are important things. Exact same questions I will not be able to predict, no one will be able to predict exact same questions. Yes, questions theme, questions logic, questions concept, that will be repeated. Yes, that I can say with guarantee. That happened in last year's year before that as well, so that I can guarantee you. But if you say that exact same question will come, no. Okay, but yes, theme of the question, the tackling of the question, the criticality of the question, that will be coming, that will be repeated, that has been repeated, and that will be repeated this year as well. A solenoid of inductance 2 Henry carries a current of I ampere. The magnetic energy stored in the solenoid is 1 joule. The value of I is, so we know that energy stored in a inductor is given by half L I square. Okay, so E is given as 1 joules, half, and inductor is 2, so I square. So I will be equals to 1 ampere. Very simple, I is 1 ampere. Okay. Next, this is very this question is from one of previous year's KCET paper. The direction of current induced in the loop ABC is shown in the figure is. Now this question you may have practiced during your PU board exam as well, because this is one of the previous year question of KCET. Now it is included in your PU board model paper as well. So and when it came, still student find this question difficult. Okay. So if similar question is coming in your KCET exam, first step is to find the magnetic field which is there because of the current carrying wire. Now configuration might change. Configuration might, they might say that there is a wire like this, it is falling like this. Okay, so based on that, this kind of questions might come. Now, first step is to find the magnetic field which is there because of this wire. So, how to find the direction of magnetic field due to a current carrying wire? Place your finger in the direction of current. Place your finger in the direction of current. Then you curl your other fingers, all other fingers, 4 fingers. Then these give you basically the direction of magnetic field. So, if you put your thumb along the current and curl your fingers, then that is the direction of the magnetic field. So, magnetic field is into the page of the paper throughout the current carrying wire, throughout this loop. Okay, so this is the already prevalent magnetic field. Now, let us understand the concept of induction. What happens in induction? If this original magnetic field is increasing, that is, if the current is increasing, original magnetic field will increase. Okay, so original magnetic field increasing means induced field will try to oppose it, so the current will flow in this direction. Okay, so that the induced EMF in the wire is outward. Okay, if the B is increasing, if the B is decreasing, then the induced current will be such that it will try to enhance the decrease. It will try to stop. Always the induction current always try to oppose what is excuse me. The induction current will always oppose whatever change is happening. Okay, if it is increasing, it will try to decrease it. If it is decreasing, it will try to increase it. These two factors, if you understand, you will be able to answer any induction based questions. Okay, if current is constant, no induction happens. Okay, that is, there is no change, no induction happens. Okay, so if the current is constant, induction does not happen at all. Now, as I mentioned, if the current is increasing, then induced EMF will be outward. For a circular object, how to find the direction of magnetic field? If current flowing like this. Now, for circle, it is opposite. First you curl your finger, then your thumb will give the magnetic field. In case of straight wire, thumb gives the current, finger gives the magnetic field. In case of circular wire, finger gives the current, thumb gives the magnetic field. So there is a small change. Okay, so magnetic field here is outside if current is increasing, so it will be ACB. So ACB if the current is increasing, but so here it is given as current is decreasing, so this is wrong. ABC if decreasing. Okay, so ABC might be correct. Okay, so ACB is decreasing is wrong. Okay, ABC is increasing is also wrong. Why? Because it should be ACB. Okay, we figured that out. If you figure one out increasing, then remaining you can directly cancel 2 options. Only one of them will be left, that is this one. Okay, you don't need to analyze this one, you just figure out if current is increasing, what will be the direction. The direction will be ACB. Okay, so ACB decreasing is wrong, ABC increasing is wrong, because the direction is ACB. That means only ABC if the current is decreasing is correct. You can check that out. If current is decreasing, it will be along ABC. So it is increasing or decreasing is given in the question. Okay, increasing or decreasing is given in the question. Okay, if the current increases, magnetic field increases. Okay, if the current increases, the original magnetic field increases. Now based on that, there will be an induced current. So you have to give the cause to the circuit, the cause to the loop to change its position. Otherwise, it is just as lazy as you. If there is no exam, you will not study, you will sleeping. Okay, you will be playing Free Fire or PUBG. I don't know PUBG what they call today. Okay, so anyway, so the same thing is with the loop also. If current is constant, it will do nothing. It will sit quietly and do nothing. But if the current is increasing, okay, if the current is increasing, it will try to stop it. Current increase or decreases, that will be mentioned in the question itself. So if you read the options, you will be clear. Okay, there are some cases current can be increased, current can be decreased. Okay, there is another case where you have a current carrying wire. Okay, loop is falling towards the wire. So in this case, magnetic field, whatever is passing through the loop, it always increases, because as it's coming closer and closer to the wire, okay, the magnetic field lines increasing. So it should induce a current which is opposing it. So that is one case. Okay. And if it is falling like this, then the magnetic field is decreasing. So that if it is a situation based question, then you have to first figure out whether current is in magnetic field is increasing or decreasing. Closer to the wire, more magnetic field; farther from the wire, less magnetic field. Okay, so there is a gravity based question. This question is also sometimes being asked in a different format. Okay, and if the wire is allowed to fall like this, nothing will happen, because magnetic field throughout the wire, throughout this plane, will be constant. Okay, if you ask the same question, so there is a wire, you have a loop here, you allowed it to fall, so whatever magnetic field throughout this zone, okay, everywhere magnetic field is constant. So because the magnetic field constant, nothing will happen, no induced current happened here. Okay, but if current changes here, then there will be induced current. Okay, and how to figure out? Your hand. Only way to answer this question is using your hand. Okay, hand gestures. So first you figure out the magnetic field. That is very easy. Point the finger in the current and your finger will give you the direction of magnetic field. You figure that out. Next, if the current increases, original magnetic field is inside, current increasing, magnetic field inside is also increasing, so induced current will try to stop it. So induced current will be such a way that induced magnetic field is outside. So induced magnetic field outside, that means current will be ACB. Okay, ACB. Okay, so if you figure one point out, you can answer all other queries because we know that increasing means ACB. So if increasing is ABC given, that is wrong, because we figured that out. ACB increasing, so ABC increasing, wrong. ACB means increasing, so ACB decreasing is also wrong. So ABC decreasing is possibly correct answer. Okay, clear? I have explained enough time, right? Does the current upward direction indicate increasing? No, 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 no. Upward direction indicates current is basically going in this direction, and you have to find the corresponding magnetic field. Okay, suppose, let me give you one more example. Suppose current is falling down, and instead of circle they have given a square loop. Same question. It does not matter what is the direction of current. Current, generally this represents direction of current. So direction of current is important to find the direction of magnetic field. So as you can see here, the magnetic field is outward. The magnetic field is outward. Upward current indicates magnetic field is inward. That's it. Okay. Now if the same question is asked, the loop is given in this side. So first step is to find the direction of magnetic field due to this current carrying wire. So this upward or downward arrow actually gives you the direction of magnetic field only, not increasing, not decreasing. Increasing or decreasing has to be mentioned in the question itself. Okay, either they will mention what will be the direction of current if current increases. Okay, so either it will be mentioned here or it will be mentioned in the options. Okay, clear? Shiva, I explained 3 times. Real geoverse, if you have prepared for last 3-4 months, definitely you will score 60 plus. Okay, if you have prepared, if you are following our all the series lectures, then also you will score 60 plus. Don't worry, 60 marks in physics. Okay, if you are even if you are preparing on your own for last 3-4 months, at least 5 to 6 months good hard strong preparation required to score exact 60 marks. Okay, so don't be disheartened if your marks is slightly less than that. But yes, 60 plus marks. Even last year also 59 was highest. Current in a coil changes from 1.6 ampere to 0.2 ampere in 2 seconds, indicating an EMF of 2.8 volts. The value of self-induction in the coil is. So current in the coil changes from 1.6 ampere to 0.2 ampere. And what is the time? Time is 2 seconds. Okay. The change in current is 1.6 minus 0.2, that is 1.4. Now obviously do not use the sign of negative, always do largest minus smallest, except for potential based questions. Okay, potential based questions, be it first PU or second PU, you always use final minus initial. In these cases you don't need to use the sign, especially for induction based question. So di by dt is 0.7. Okay, dt is given here 2 seconds. So change in current is di, change in time is 2 seconds. Now inducing an EMF of, so induced EMF is given by L di by dt. Okay, so what is self-inductance? So the induced EMF is 2.8 volt, L is 0.7, and di by dt, sorry, not L, my mistake, L we are trying to find, and di by dt is 0.7. So L is equal to 2.8 by 0.7, which is 4. Okay, so which will be 4. So 4 Henry is the answer. Simple, easy, no rocket science. A body has a charge of 3.2 microcoulomb, the number of excess electrons it has. So in my yesterday's lecture I gave you 1 nanocoulomb. I taught you a shortcut for that. Now today's lecture I have giving you a easy option, which is 3.2 microcoulomb. Don't ignore the number. Obviously this is not question number 1. Okay, actually I prepared a PPT, then I thought, okay, let me add some more questions. So the questions that you have seen so far are the extra added questions, and this was supposed to be my actual lecture. Okay, so I have added extra questions, more than 50 questions. That's what I said. Okay, a body has a charge of minus 3.2 microcoulomb, the number of excess electron it has. So obviously Q equals to Ne, and excess electron is Q by E. Now this is very good method of solving if the value is multiple of 1.6, where it is here. So 3.2 micro means 10 to the power of minus 6 divided by 1.6 into 10 to the power of minus 19, which will be obviously 2 into 10 to the power of 13. Okay, so 2 into 10 to the power of 13 is correct answer. But in some cases, as I mentioned in my yesterday's lecture, I will remind you once more, those who have missed yesterday's lecture, if instead of giving 3.2 microcoulomb, if it is given 2 coulomb, 5 coulomb, okay, 1 nanocoulomb. So in those cases what you have to do, take the charge, okay, 1 nanocoulomb, suppose nanocoulomb means 1 into 10 to the power of minus 9, and multiply it with a factor of 6.25 into 10 to the power of 18. This is the shortcut direct way to find the number of charges. Okay, this is the shortcut way, but this is more beneficial when the charge is 1, 2, 5, 7, 10, like that. If it is 1.6, 3.2, 32, 48 or 4.8, if it is a multiplier of 1.6, then this method should be more beneficial. Okay, 6.25 into 10 to the power of 9. So this is the topper's secret. This one is a topper's secret. Toppers solve quickly because they know this kind of tricks. So that's how they solve quickly. Based on the question, they decide which strategy to use. Okay, whether I will use this strategy or that strategy. Okay, so that's how you should use. If it is a straightforward multiplier of 1.6, you use your old known formula. If it is not, then use this shortcut. Okay, so remember this might be handy. A charged particle of mass m and charge q is released from the rest in an uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds is. So you have to find the kinetic energy, right? And mass is given, charge is given, electric field is given. How to solve it? completely different genre of question. Electric field, charge, kinetic energy, oh my god. Don't worry, we know that force acting on a charged particle is given by Q into E, right? So this is known. And our great grandfather Newton, who some of you might want to kill, if I meet Newton, I will kill him. Okay, I will time travel and kill Newton. So many of you think in your head when you are kids. Okay, so our great grandfather Newton has said father equals to ma. There is no difference between them. So F equals to ma. Okay, so from here we calculate acceleration QE by m. Okay, QE by m is our acceleration. So we have calculated acceleration. Now velocity after time t. So velocity after time t is a into t. V is equal to u plus at starting from rest. So starting from rest means u is 0. So velocity we have calculated a into t, which is QE t by m. Now kinetic energy is half m v square. Okay, so this problem, now you decide whether it is an easy question or a difficult question. Okay, considered in KCET to be difficult question. Okay, so it will be Q square E square T square by M square. Okay, obviously not very easy question, but according to KCET standard, this is considered a difficult question. Okay, so obviously the correct answer is Q square E square T square by M. So here this is T. This is T. Okay, this is not R. There is no R here, so it will be T. Okay, so Q square T square by 2M. Okay. If you understand the concept from this lecture, then you can score more than 25. You can score 35 to 40 questions very easily. Okay, 35 to 40 questions very easily. If you have attended last 3 lectures, 100 question, 60 questions and today's session, you should be scoring more than 45. Okay, that is my guarantee if you understood the concepts. Okay, that is my guarantee. The force of repulsion between two identical positive charges when kept with the separation r in air is F. Half the gap between the two charges is filled by dielectric slab of dielectric constant 4. Then the new force of repulsion between the two charge becomes. Now here this is also very common question. Here we have two charges Q1, Q2. Okay. Now originally the force is given F, so F is equal to K Q1 Q2 by R square. Now dielectric constant. Okay, dielectric constant, even though we write Coulomb's constant with K, dielectric constant is also written as K, but it is written as capital K. Okay, so those might be a little confusing. So dielectric constant is given here 4 and half the gap, not entirety of the gap is filled. So half the gap is filled by K, dielectric constant. Okay, so now what will be the force between them? So this is very interesting topic. So how to tackle? Now first I will ask you to remember one very important thing is that suppose we have a dielectric slab. Okay, we have a dielectric slab and we have a dielectric constant K. If we keep two charges exactly on this edges Q1 Q2, the distance between them is x. Okay, then the force between them is given by K, that is Coulomb constant K, Q1 Q2 by x root of K whole square. Okay, x root of K whole square. So this derivation obviously I am not doing it. So this is very fundamental equation. Now remember, basically what does that mean? If these two charges are kept in air, if these two charges are kept in air and kept at a distance of x root K, whatever force is acting between them, The same force will act if they are kept at a distance x and charges are same. Okay, so basically this is called equivalent free space length. Equivalent free space length. That means dielectric medium, you convert it into equivalent free space length. Okay, so this is a short conversion that you have to remember. Now in this problem, only half of the distance is covered. So if the total distance is r, only r by 2 is covered by dielectric medium. Remaining r by 2 is still outside. Remaining r by 2 is still outside. So that makes this problem slightly complicated than the case we have discussed. Okay. Now, so dielectric medium of constant K, so this has a length is r by 2 and remaining r by 2 is already in free space. So that means what is the equivalent free space length of this medium? So equivalent free space length is, as I mentioned, r by 2 into root over of K. And this portion is already in free space. This portion is already in free space. So basically we need to add these two lengths, but directly we cannot add. Obviously one is inside a dielectric medium, another one is inside free space. So basically first convert this length into free space length, then you add it. So this is the trick, this is the formula that you need to remember. So r by 2, K is given as 4, so root 4 is 2. Okay, K is given as 4. If you read the question, here it is mentioned dielectric constant 4. Okay, so that means plus r by 2, which is r plus r by 2, which is 3r by 2. So this is the new distance. This is the new distance. So what will be the new force? So new force will be given by, top part will remain same, only the bottom part will change, which is 3r by 2 whole square, which is 4 by 9. Okay, K Q1 Q2 by r square. Okay, so it will be 4 by 9 F. Okay, it will be 4 by 9 F. So correct answer option D. Okay, this kind of questions are easy but tricky. This kind of questions are considered medium difficulty. This is a easy question, very easy question, considered easy in KCET. If AX and EEQ represents electric field at a point on the axial and equatorial line, so this one is axial, this one is equatorial, okay, of a dipole, if the points are at a distance from the center of the dipole for r very, very greater than A, obviously this is the approximation we do, then which of the relationship is correct? Obviously we know that axial is twice that of equatorial plane, and when you add vector sign it becomes negative. Okay, so axial is twice that of equatorial plane and the direction is opposite because axial is along the direction of dipole moment, equatorial plane is opposite to that of the dipole moment. So that's why there is a negative sign. So do not ignore the negative sign. So the correct answer is C, not D. Okay, C, correct answer. C option, because axial is given by 1 by 4 pi epsilon naught p vector by r cube. Okay, and equatorial plane vector is given by 1 by 4 pi epsilon naught minus p vector by r cube. Okay, because there is a minus sign, there is a minus, and because it is twice stronger than this, so there is a 2 factor. Okay, if you remember this, well and good. If you don't remember it, you just remember this, that will also do. Now next question, pick out the statement which is incorrect. So 3 are correct, 1 is wrong. The electric field lines forms closed loop. So first statement itself is wrong. Electric field do not form closed loop. Electric field forms open loops. Only magnetic field forms closed loop. So this is our incorrect statement. We found our incorrect statement in the statement number 1. In the exam, maybe that will be given in statement number 3 or statement number 4. That you have to figure out by reading the options. The angle between dipole moment and electric field at any point on the equatorial plane. So as I mentioned, equatorial plane, okay, that dipole moment is in this direction, electric field is in this direction. So electric field in equatorial plane, dipole moment in for a dipole. Now dipole moment for a dipole is always same. So that means if you take both of them, if you draw both of them from the same point, you will find the angle between them is 180 degrees. Okay, so angle between them is 180 degree. And for axial case, electric field and dipole moment are in same direction. The angle between them will be 0. Okay. A spherical conductor of radius 2 cm is uniformly charged with 3 nanocoulomb. What is the electric field at a distance of 3 cm from the center of the sphere? So we have a sphere. Okay, it is sphere or shell, does not matter. If it is a conducting sphere, the answer should be same. Okay, radius given here is 2 cm. Okay, and the charge given here is 3 nanocoulomb. You are trying to find electric field at a distance 3 cm. Okay. Okay, now here as you see that this distance r is greater than r, right? So small r is greater than capital R, that means the point is outside. So the electric field is given by k q by r square. If it is inside, electric field will be 0. Okay, so k is 9 into 10 to the power of 9, q is 3 nanocoulomb, and r is 3 centimeter. Now 3 centimeter you have to convert it into meter. So what students make mistake is that even after solving it properly, they forget to convert this centimeter to meter and they answer the question wrongly. Okay, so there is a trap everywhere, even the wrong answer is given here. So it will be 9 into 3 divided by 9 into 10 to the power of minus 4. 9 cancels, you get 3 into 10 to the power of plus 4. Also, another mistake that you guys make is that you forget to change the sign of 10 to the power when you are changing it from division to multiplication. Okay, so that is one very important part. So after solving this, 10 to the power of minus 4, because you are in a hurry. That anxiety and that tension can arise from the exam stress. Okay, that is very common, but if you stay little calm, you should figure out, you should avoid mistakes, step by step process, then definitely that you will be able to answer. Okay, A is correct answer. Now let's move on to the next question. In a uniform electric field, E exists along the horizontal direction as shown. The electric potential at A is VA. A small point charge Q is slowly taken from A to B along the curved path as shown in the potential energy of the charge when it is at point B. So potential energy of the charge at point B. So we know that potential energy of a charge is given by Q potential. So basically potential energy at B will be Q into VB. One line answer. But the problem is VB is not given in the question. So you have to first find VB. Then you can use this formula to find the potential energy. Right? Now, first is you have to figure out that electric field is given in this direction, and suppose the potential at A is VA given, and at B at VB we are saying the distance between the point is x. Okay, we know that electric field is given by minus dV by dx. Okay, minus dV by dx. So dV is what? Final potential minus initial potential divided by distance between them. Okay, so this is dV by dx. Now you can calculate VB from this formula. Okay, so you simplify Ex equals to minus VB plus VA. Okay, so VB equals to VA minus Ex. Okay, so VB is equals to VA minus Ex. So the work done will be Q into VA minus Ex. So correct answer is Q into VA minus Ex. Also, one more important thing that you should remember, if you are moving in the direction of electric field, electric potential always decreases. If you are moving in the direction of electric field, electric potential always decreases. If you are going from here to here, potential increases. If you are going in the direction, potential decreases. Okay, so this is also very important, and this curve path does not matter. No matter what path you take, the potential energy will always be Q into V. Okay. Two tiny spheres carrying charges 1.8 microcoulomb and 2.8 microcoulomb are located at 10 centimeter apart. The potential at midpoint of the line joining two charges is. So easy question. Here we have two charges, Q1, Q2, and they ask you potential exactly at the midpoint. So suppose this is R, this is R, the total distance is 2R. If you see in the question, 2R is given 40 centimeter, so 2R is 40, R is 20, but you have to convert it into meters. Do not forget that at any cost. So potential at the midpoint between two charges, I am teaching one more trick, potential between two charges at the midpoint. If this is asked at the midpoint, you can use this. Okay, that is given by Q, sorry, not Q, K divided by R. R is the half length into Q1 plus Q2. Okay, you don't need to calculate them individually and add them. You directly use this and solve it. 9 into 10 to the power of 9. R is 20 into 10 to the power of minus 2. Q1, Q2 is 1.8 plus 2.8, which is 3.8, 4.6. 4.6 into 10 to the power of minus 6. Okay, so now let's simplify. You cancel 10, you get 2.3. So it should be 2.3 into 9. 2.3 into 9 is 18 plus 2.7. 18 plus 2.7 is 20.3. 20.3. Now let's calculate the 10 to the power values. 9 minus 6 is 3. 3 plus 1 is 10 to the power of 4, or 2 into 10 to the power of 5. Approximately this is the answer. So if you see, the correct answer is this. Okay, so correct answer is 2.1 into 10 to the power of 5. Right? Clear? Saida Sara, there are a lot of questions left. Okay, we are solving more than 60 questions in today's session. Okay, as I mentioned, a parallel plate capacitor is charged by connecting 2 volt, but we will not take too much time. By 12:30 I will try to close the session, maximum by 1. A parallel plate capacitor is charged by connecting a 2 volt battery across it. It is then disconnected from the battery and glass slab is introduced between the plates. Which of the following pairs of quantities decrease? So we have a glass slab, we have a capacitor. Okay, we have charged it, fully charged it, and disconnected from the battery. Now we have introduced a glass slab between the plates. So when you introduce a glass slab between the plate, okay, it has a dielectric constant. So capacitance of the new capacitor will be K times the old capacitance. So capacitance increases. Capacitance increases. Okay, and what about the charge stored in the capacitor? Charge stored in the capacitor remains constant because capacitor is an isolated system now. So charge stored in the capacitor should remain conserved. So charge is conserved. So charge is constant. Now if you read the option, energy stored and capacitance, charge and potential difference, capacitance and charge. So whenever you see capacitance and whenever you see charge, okay, those are wrong answers. Capacitance increases, potential charge remains same. So only combination is potential difference and energy stored. So these two are decreasing because in the question it is mentioned which of the quantities decrease. Okay, so always remember once the battery is removed, the charge remain constant. If the system is still connected to the battery, okay, then charge should change. Okay, it should charge to more, the charge should increase. But because the battery is removed, the charge should remain constant. Next, if a slab of insulating material 4 into 10 to the power of minus 3 meter thick is introduced between the plates of parallel plate capacitor, the separation between the plates has to be increased by 3.5 into 10 to the power of minus 3 meter to restore the capacity to the original value. The dielectric constant of the material will be, this is a PYQ. So the question states that we have a capacitor. Okay. Now here we have introduced a slab of D, suppose thickness D. To maintain the same capacitance, we have to increase the distance, okay, and the increase is given by X. So this is the problem basically. Original length was D. Now we have introduced a glass slab, and to maintain the same capacitance as original, okay, same capacitance as original, we have to introduce a gap of X between the plates. This place is air, this place is gap. This place, this is the place where the, this is the place where we have the dielectric medium. Now there is a shortcut formula, you can do mathematics. Obviously we have done that in past as well, but there is a shortcut formula that the dielectric constant is given by the thickness of the dielectric medium divided by thickness of the dielectric medium minus by which the gap is increased. Okay, so D divided by D minus X. D is given by 4 minus 0.3. Now you might say, sir, there is a 10 to the power of minus 3 there. Don't worry, 10 to the power of minus 3 will cancel from both divisions. Okay, so don't worry about 10 to the power, just check the values are same or not. If they are same, no need to worry. So you will get 8. Okay, so 8 is the answer. So 8 is the dielectric constant. Okay, so remember this formula. Next, an electrician tell me the names who are disturbing in the lecture. I will start blocking. I cannot find because most of you are listening to the class. If I see anyone talking, I will start. I cannot focus on the chat, right? I have to teach you. An electrician requires a capacitance. So please guys focus here. This question is very, very important and interesting question. One of my favorite question. An electrician requires a capacitance of 6 microfarad in a circuit across potential difference of 1.5 kilovolt. A large number of 2 microfarad capacitors which can withstand a potential difference of not more than 500 volts are available. The minimum number of capacitors required for the purposes. So here we have a capacitor. Okay, the capacitance is 2 microfarad. The voltage rating of this capacitor is 500 volt. But we want a capacitor of 6 microfarad. But the catch is we want the voltage rating to be 1500. So if you use this capacitor directly to form a 6 microfarad, the capacitor will be burned immediately because it will not be able to handle 1500 volt. Okay, 1.5 kilovolt means 1500 volt. So it will not be able to handle it and it will burn. So how to do that? How to tackle that? For that we have to do one very interesting thing, which is we have to use 3 capacitors in series such a way that now this combination can handle 1500 volts. So this is 500, this is 500, this is also 500. So all the voltages are getting added, voltages always gets added. So now 500 plus 500 plus 500. So total voltage that this combination can handle is 1500 volt. But the equivalent capacitance of this combination is not 6 microfarad. Okay, equivalent capacitance is 2 microfarad, 2 microfarad, 2 microfarad. They are in series, so don't confuse. So it will be the equivalent capacitance will be 2 by 3. Okay, for n capacitors connected in series having same capacitances, it is C by n. C is 2, n is 3, C by n. Okay, so equivalent capacitance is 2 by 3. But our target is to make it 6 microfarad. So how to handle that? So voltage part is now maintained. Now we have to figure the capacitance part. Now we have to apply parallel combination. Only way to increase capacitance is connect them in parallel. So we have to apply similar configurations in parallel, okay, so that the total equivalent capacitance becomes 6. Okay, so now suppose we have n such total number of, I say this is rows, total number of rows are n. If we have n number of rows, okay, then what is the final equivalent capacitance? Final equivalent capacitance is obviously 6 microfarad, and that should be equals to n times this. Okay, so n times 2 by 3. Okay, so n equals to 6 into 3 by 2, which is 9. So n is the number of rows. Okay, 9 rows. We need 9 such rows to make it 6 microfarad. Each row has 1, 2, 3 capacitances. So total number of capacitance will be 3 into 9, that is 27. So we do not require 1, 2 or 3. We require minimum 27 capacitors to make it handle 1500 volt and the equivalent capacitance of 6 microfarad. Okay, so very interesting question. That's why it is one of my favorite question. Okay, yes, 9 rows, 3 capacitors per row, 27 total. Correct. Now this is a visual question. Okay, question is easy, but visually little tricky if you are not prepared for visual tricks. The equivalent capacitance in this given case. Okay, equivalent capacitance for this given case. How to solve this? So it might feel like this combination is parallel to this combination and this combination is parallel to this combination. But if you look closely, here is a cut. Here is a cut. So you are not finding the equivalent capacitance in this way. If this is the way, then the logic is correct. Okay, this is parallel to this one and this one, but that is not correct because here there is a cut here. Okay, if you see there is a gap here. So what is the first step? First step is okay, this one is parallel to this one. So 100 and 100 are in parallel series, 100 and 100 are in series, so two equal resistances in series, so always divide by 2, you get 50. Okay, so 50 is the equivalent capacitance. Now this 50 is in parallel with another 50, so 50 parallel with 50 will give you 100. Okay, 50 plus 50 gets added, parallel combination of capacitors gets added. Now you have to find 100 over here, that is the top portion. Okay, now this 50 is not connected in parallel but in series. Okay, because this point is A, this point is B. Okay, because there is no connection between A and B, 150 are connected in series, not in parallel. So now, so equivalent capacitance is 100 into 50 divided by 100 plus 50. So it will be 100 into 50 by 150. 0, 0 cancels, 3. So correct answer is 100 by 3. So correct answer is 100 by 3. Okay. Now, in the part of the circuit shown in the figure, the potential difference between point G and H, Vg minus Vh. Okay, so this is a part of the circuit shown. This question is part of our Abhyas test series. Okay. You might think this is a very difficult, complex question. Actually, it is not. Okay, if you do step-by-step analysis, this is actually easy question. So if you see here, 2 ampere input current is given. First of all, which points we are finding? G and H. So we have to find Vg minus Vh. Okay. Now 2 ampere current enters from G, and if you see here, 1 ampere current exiting here, 3 ampere current exiting here. Current information about this resistance is not given. Okay. So first we have to start at the end. Start at the end. 1 ampere, 3 ampere. That means both are outgoing, so incoming current must be 1 plus 3, that is 4 ampere. So 4 ampere current must be going in. So from where we will get the 4 ampere? There is no other thing. So 4 ampere current must be coming from here as well. And if you see that this 2 ampere current has to reach here. So 2 ampere current is coming from this side. 4 ampere current is exiting. So from where we are getting the extra 2 ampere current? The extra 2 ampere current must come from this portion. Okay, so basically this information is given to you so that you apply the back calculation and find the current that is passing through H is 2 ampere. Very easy, simple. Now, so current through this is 2 ampere. Now if you are confused how to calculate Vg minus Vh, there is circuit is not completed. For those, you can do one thing. Let us add a battery. Okay, let us add a battery such a way that you are getting the same thing. Okay, so suppose this is Vg minus Vh. The EMF of the cell is Vg minus Vh. Okay, so this is sending the current in this direction, which we prefer. Okay, obviously that is not correct. Just imagine in your head. So there is a battery connected which is actually sending the current that we require. Okay, so now you apply Kirchhoff's law. So 2 ampere into 4 ohm. 2 ampere into 4 ohm. 2 ampere into 4 ohm. We are going, ignore the battery for now. Ignore the battery for now. We are going in this direction. Okay, so 2 into 2 ampere. 2 into 2 ampere. Next we are going in this direction because we have to complete the circuit. We have to complete the circuit. Now we are going in the opposite direction of the current. So minus 1 into 2. 1 into 2. This is the total voltage drop across different resistors. And that should be equals to the source voltages. What are the source voltages? Here we have a 3 volt source. which is positive. Why it is positive? Because we are going in this direction and the battery is also trying to send the current in the same direction. If the direction that we have taken and the current that is being sent by the battery are same, then battery voltage is positive. And we have taken this source such that this becomes positive, because that is what we are trying to find. So Vg minus Vh. Okay, Vg minus Vh. And now you calculate 8 plus 4 minus 2 equals to 3 plus Vg minus Vh. So Vg minus Vh equals to 10 minus 3, that is 7 volt. Okay, so if you figure that out, then this is an easy problem. Okay, but even in KCET level, it is a medium to difficult level question. Now answer this question. I will give you 5-minute small break. 5-minute small break. But when I come back, I expect you to solve this question. I need to have some water and tea. So I will come back in 5 minutes. But till then, you solve this question. So are you able to solve this question? Who have answered this? Option D, option D, option D. Yes, option D is correct. Option D is correct. So this is basically this kind of structure. If you see, they are Wheatstone bridge. Okay, these kind of structures are Wheatstone bridge structure, and in case of Wheatstone bridge structure, what you have to see, this by this equals to this by this or not. So here R by R equals to 1, R by R is also 1. So that means the Wheatstone bridge is balanced, and this one is actually representing the galvanometer. So that means it does not present in the circuit. So basically we can simply erase it. Now I cannot erase it, I can scratch it off. Okay, so basically this portion does not exist. So this portion does not exist means basically what does that mean? That means here this R and R are in series, and this R are in series with this R. Okay, R. So now, so if you calculate the equivalent resistance, R plus R is 2R, R plus R is 2R. So 2R and 2R are in parallel, therefore the equivalent resistance is 2R by 2, which is R. So now one shortcut trick that I am going to teach you, if you see a circuit where all the resistances are same in a Wheatstone bridge, this galvanometer resistance does not matter except the galvanometer resistance. If you see all the resistances are same, then you should remember that the equivalent resistance of the galvanometer is basically same as these values. So the equivalent resistance of this component is actually equals to R. Similar logic, we can say that this R is not present, so basically we can scratch that off, we can cut it and remove it because no current is flowing there, so galvanometer is off. So galvanometer off means that portion of the circuit is not active. So basically you can again find the equivalent resistance. This one will be 2R. Obviously same logic that we have applied in this case, all resistances are same, so the equivalent resistance is R, all resistances are same, equivalent resistance is 2R. Now to confuse you, maybe they will give you a galvanometer resistance completely different. They might give you galvanometer resistance say 3R or 5R or 10R. So that resistance does not matter. This resistance does not matter, whatever value it has been given here. Okay, because it is eventually not present in the circuit. So now R and 2R are in series. So total equivalent circuit of this circuit is R plus 2R, that is 3R. Okay, so what is the voltage? Voltage is given by V0. So current is given by V0 by total resistance, that is V0 by 3R. So current is V0 by 3R. So option D is correct. Right? Now let's move on quickly. If voltage across a bulb rated 220 volt 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which power would decrease by. So percentage change problem, so any percentage related problems, always first try to find out the relationship between the quantities mentioned. So here if you see that voltage and power is given, so what is the relationship between power and voltage? Voltage and power is related by V square by R. Now you might say, sir, why we are not using another formula, P is equal to VI? That is because if you change voltage, current will also change. Okay, power is changing, not only power is changing, current is also changing. Current and voltage are dependent on each other. But the resistance of a bulb obviously will not change because the bulb is fixed. So resistance, the wire length, material, everything is fixed. That means the resistance of the wire will not change. So this is a constant quantity. That's why we have written this. So based on the question, you have to identify the variables and then write the equation properly so that you understand what is constant, what is variable. Right? Now you have to differentiate this. So dP equals to 2V dV by R. 2V dV by R. Now divide both side by P. So we will divide this side by P, but this side with the other side, that is V square by R. Okay, so this R cancels and you get dP by P equals to 2 dV by V. Okay, if you cancel this V, one of the V will cancel and this will be the equation. Percentage change is basically this one. If something is said percentage change refers to this value. So 2.5% percentage change means this one, 2.5, and that will be equals to dV by V. Okay, so this is the percentage change in voltage. So percentage change in voltage is dV by V equals to 2.5 divided by 2, that is 1.25. So correct answer is, unfortunately the correct answer for this question is not given. Okay, I think it should be 1.25. So this is the correct approach to solve this question. Okay, I think while typing the question some mistakes happened and correct answer is not given, but this should be your approach when you are solving the question. Okay, so power would change. Oh, sorry, my mistake. So power change is not given. Sorry, extremely sorry. Change in voltage is given. Okay, voltage is dropped by 2.5%. Okay, you are trying to find the change in power. So change in power you are trying to find. Okay, and the change in voltage is given here 2.5. So it will be 2 into 2.5, that is 5%. Okay, dV by V is the percentage change in the voltage. dV by V is the percentage change in the voltage. So percentage change in the power will be 5%. So correct answer is 5%. Okay, so this should be the approach whenever you are seeing okay, a wire of resistance 3 ohm is stretched to twice its original length. The new resistance of the wire will be. If I see only this one video concept is enough to score 25 marks. I already told you, Mahantesh, I already informed. Okay, yes, 25 marks you might get if all the questions are coming based on this concept, but I will not recommend watch only one video. 100 plus 50 plus 60, that should you watch. Okay, then 35 to 40 marks you will get. A wire of resistance 3 ohm is stretched to twice its original length. So initial length was L, final length is 2L. Okay, so the factor by which the length changes is given by this. Now as I mentioned, always if you want to know the theory I can explain, but always remember that the new resistance is N square the old resistance. So if you identify the factor, okay, if you identify the factor, just N square R. N is here 2, so 2 square into 3, that is 12 ohm. So correct answer is 12 ohm. Now how this formula came, I can explain that, but you do not have time. Just remember that you have to identify this N. If it is doubled, tripled, quadrupled, N is 2, 3, 4. Okay, if it is halved, N is half. Okay, if it is increased by 20%, this kind of questions are also common. Increased by 20%. Increased by 20% means N is 1 plus 2 by 100. 20 by 100. Okay, N is 1 plus 20 by 100, basically 1.2. 20%, 30%, 50%. Length is increased by 50%, that means 1.5. Okay, length is increased by 300%. Length is increased by 300%. 300 by 100. 1 plus. Okay, so 4. Length is increased by 300% means factor is 4. So if you percentage based questions are also common. Only thing you need to identify is this N and N square R. That is the formula. Okay, That is the shortcut formula. Next, so this is another tricky question. I know most of you will ask this question. In the given circuit, the current through 2 ohm resistor is, I given this question in my 100 question series, and many of you asked why, how this happened, why this happened. So let me explain this once more. Okay, so if you see that here we have a circuit, and in this circuit there is a resistor, there is a resistor, these two resistors are there. Okay, leave it. Here suddenly there is no resistor. Okay, there is no resistor. So let me redraw this circuit for you so that whatever doubts you have, that is clear. Okay, we are not drawing up to this part, we are drawing this part. So if you see that this resistor is here, so we draw this. This resistor is here, but nothing is in between, so this resistor we can draw like this. So this is 3 ohm, this is 1 ohm. Okay, so we can draw it like, right, because this point is directly connected between these 2 points. So basically if I draw it like this, no harm is there. Now there is a straight line without any resistances, so this is here. Now here we have one resistance on this side. Here we have these two resistances connected in series. These two resistances connected in series, so 1 plus 1 is 2, and that combination is connected parallel. This combination is connected parallel to this. Okay, so 1 plus 1, so this is 1, this is 1 plus 1, that is 2. Okay, so if you find the equivalent resistance of these two, okay, suppose that value is X. I am not doing that. Okay, that suppose that value is X. Now you can say this 1 ohm and this X are in series. This 1 ohm and that X are in series. So the equivalent circuit becomes 1 plus X. 1 X is this part. So now you see we have 1 resistor, 2 resistor, 3 resistor and a straight wire. All of them are connected in parallel combination. All of them are connected in parallel combination. Okay, so what is the resistance of this wire? Resistance of this wire is 0. This is called short circuit, so resistance is 0. We have 2 more resistances here. That resistances I am not discussing. Okay, we will discuss that later. So the resistance of this wire is 0. Now if you try to calculate the equivalent resistance, what will be the equivalent resistance? So 1 by R equivalent equals to 1 by 3 plus 1 by 1 plus 1 by 0 plus 1 by X plus 1. Right? So if you try to calculate equivalent resistance, now what is this quantity? Obviously this is infinity. So this is, as soon as infinity enters, everything disappears. Okay, so that will be infinity. So no matter what you add with this, it will still be infinity. So now what will be R equivalent then? R equivalent is 1 by infinity, and 1 by infinity is 0. Right? So 1 by infinity is 0. So the equivalent resistance of all these complicated circuit is actually 0. That means you don't need to consider this resistance, this resistance, this or this. Okay, so these resistances are not contributing in the current. Okay, because the equivalent resistance of this entire portion of the circuit is a big 0. Okay, so that's why. So last time I just explained it without doing any mathematics. So I hope that now it will be beneficial, helpful for you, that why we are saying that if there is a circuit of parallel combination, okay, parallel combination circuit is there. In between parallel combination, if there is a straight wire which is called short circuit, current will not pass through this or through this. Entire current will only pass through this. Entire current will only pass through this. So no current will pass through this, no current will pass through this. This is only applicable in parallel combination. Okay. because this combination of the resistances are also in parallel, this is also not contributing towards the current. Okay, so only simplified circuit of this complicated diagram is there is a 1 ohm resistance, there is a 2 ohm resistance, and there is a this wire. Okay, the voltage is 1.2 volt, 1 ohm, 2 ohm. Okay, now you have to find the current. How to find the current? Current is basically the voltage divided by total resistance. Total resistance is 1 plus 2, that is 3. Voltage is 1.2 by 3, that is 0.4 ampere. Okay, so the diagram, the circuit looks scary, but the problem is not difficult. Only catch to solve this question is you identify that no current is passing through this. Now, why no current is passing through this? I have explained the equivalent resistance of this portion of the circuit is 0. The equivalent resistance of this portion of the circuit is 0. Someone is very, very happy, it seems. Yes, correct. Correct. So most of you have started answering this question. Let's see. N identical cells, each of EMF epsilon. How to put tukka? Check Dia, check Jasmine ma'am's video. She did a very thoughtful and research video on how to guess. In identical cells, each of EMF epsilon and internal resistance R are joined to form a closed circuit. One cell A is joined with reverse polarity. The potential difference across each cell is. So here I explained a similar question yesterday. So here we have n number of cells. N number of cells. They are connected in series. Okay. Now, in between this n number of cells, there is one cell who is connected with reverse polarity. Reverse polarity means everything is positive for all the cells, for all other cells. So this is E plus E plus E. But in between there is a negative E. And this thing continues to happen. Okay, this thing continues to happen. We have all the other cells as well. Minus plus. Okay, everything is properly connected except this one. Okay, plus minus plus minus plus minus plus minus plus, but there is a opposite connection for one cell, and they are forming a closed loop. Okay, how many cells are there? Total number of cells are n. How many of them are properly connected so that their EMFs will be added? Okay, so all of them are plus except this one. So n minus 1 of them are properly connected, so that is the EMF of all the n minus 1 cells, and one of them is incorrectly connected, so EMF of that you have to subtract. So the total EMF becomes n minus 2 into E. This is the equivalent EMF. Okay, this is the equivalent EMF. Now what? Next we have to find the current. How to find the current in the circuit? To find the current, you have to find the total resistance. Total resistance, always resistance has no polarity, it always added, so it will be N into R. Each of them have smaller resistance, so it will be N into R. So current will be N minus 2 into E divided by NR. Okay, so N minus 2 into E divided by NR. So voltage drop across any of the cell, voltage drop across any of the cell is I into R, which is n minus 2 into E divided by n. Okay, so the correct answer is option B. Correct answer is option B. If you are not listening to the class, I will block you. This, sir, these concepts will be repeated. What? These concepts will be repeated. Obviously, concepts have repeated, and it will be repeated. Okay. The following figure, what is the magnitude of magnetic field induction at point O? So here we have a circuit. Not circuit, you will say it is a configuration of current carrying wire, and you have to find the magnetic field at the center of the O. Now this has two parts. Okay, first part is this is a current carrying wire, this is a current carrying wire, this is a current carrying wire. Now if you see that this wire, if you allow it to pass, it is passing straight towards this point. So whatever magnetic field is there for this wire, it will be here, but not along the line of the wire. So this wire has zero magnetic field contribution. Now what about this wire? This wire is like a circular loop, but it only half circular loop, not a full circular loop. Okay, this is a half circular loop. So we know that magnetic field due to a complete circular loop is given by mu naught by 2 I upon R due to a complete circular loop at its center. Okay, at the center of a complete circular loop, magnetic field is given by mu naught by 2 I by R. But here we have only half of that, so we multiply half with it to find the magnetic field due to this wire. Okay, what is the direction of this field? So as I mentioned, direction of field, always use your right hand, curl your fingers in the direction of the current, thumb points the magnetic field. So magnetic field is out of the paper. Okay, this is out of the paper. So magnetic field is out of the paper. Dot means out of the paper. Now what about this wire? So this wire will have a magnetic field at this point. This wire you cannot ignore because this is a this wire is perpendicular to this point, so that means it will have a component of magnetic field at point O. Okay, how to find the magnetic field due to a straight wire? Assuming the wire goes to infinity on this side, okay, and we know that magnetic field due to a straight current carrying infinite wire is given by mu naught by 2 pi I upon R. Okay, the distance, this distance is R, this is also R. Okay, both are R. Now I am using capital R. In the question they have given small r, so no problem. So this is also R, right? So it is mu naught by 2 pi I by R, but that is for a complete full infinite wire on both sides. Here we have infinite wire in one side, another half is missing. So you can consider there is another half on that side, then you can say this is an infinite wire, but that half is missing. So basically this will also be half infinite wire, so this will also be multiplied by half. Okay, now what is the magnetic field direction due to this wire? The magnetic field direction, this is direction of current and this will be the direction of magnetic field. So this is also out of the wire. So both of the magnetic fields are out of the wire, so that's why you have to add them. Okay, if one is out, one is in, then there will be subtraction, but because both of them are outside, it will be added. Now in KCET, generally the trend is they will not confuse you out and in, they will give you the magnetic field in the same direction. So if you figure out the magnetic fields, 99.9% chance there will be some summation sign between the magnetic fields. Now let's figure out mu naught I by 4R plus mu naught I by 4 pi r. Okay, so mu naught I by 4 r and mu naught I by 4 pi r. Okay, so this is the net magnetic field at the center of the circle. This is the net magnetic field at the center of the circle. Okay. Into the plane, no. Why it should be into the plane? I don't know what sign convention you use. Right hand is the sign convention. Do not try to use this kind of sign convention for magnetic field. Simple, curve your fingers out of the plane. It is direction of current out of the plane. How can you find into the page of the plane? Do not use complicated sign convention. Right hand sign convention is enough. Okay, in induction there is a left hand rule, right hand rule, confusion is there, but those are not applicable for simple magnetic field. Simple magnetic field, simple rules. Right hand rule, right hand rule. For circle, curve first, thumb later. For straight line, thumb first, curve later. Okay, there are many other rules teacher teaches, but those are all very complicated. Remember the basic fundamental the centuries ago what Faraday has given. Okay, the law I am teaching you is not mine, obviously. It was done by a very great person called Faraday, Michael Faraday. Okay, he discovered the magnetic field due to a straight current carrying wire. Okay, and that's why we learned Faraday's law, which is called magnetic induction. That law was given by Michael Faraday, and it was centuries ago. Don't try to make things complicated. It is out of the plane here, it is out of the plane here as well. Both are out of the plane. No, nothing is into the plane. Okay, and this wire is going straight away. So straight wires, if the angle is going straight towards the point, that does not produce any magnetic field. Okay, don't confuse yourself, don't confuse others as well. An electron moves with the speed of 2 into 10 to the power of 5 meter per second along the positive x direction in a magnetic field B is equal to I cap minus 4j cap minus 3k cap Tesla. The magnitude of the force in Newton experienced by the electron is. So electron speed is given. Okay, magnetic field is given. But it is mentioned that the electron is moving in the x direction. Okay, x direction means I cap. So speed of the electron is given by 2 into 10 to the power of 5 I cap. Okay, 2 into 10 to the power of 5 I cap. Now magnetic field here is given I cap minus 4j cap minus 3k cap. Okay, so now you have to find the force acting on it. How to find force? Do not try to find the magnitude. Magnitude is will be incorrect. Force will be Q V cross B. Some student come up and they say a lot of different options. Okay, it is V cross B. V cross B is first. Okay, Q is given here. Electron. Electron means 1.6 into 10 to the power of minus 19. Now let's find V cross B. So V cross B is easy because V has only one component, so only one of them will be staying, remaining will be not one will be there, others will also be there. Let's see. So V cross B means I cross I is 0. So I cross I is 0. 2 into 10 to the power 5 is common. Okay, V cross B. Okay, I cross I is 0, so first term is 0. I cross J. So remember this clock rule. This is clock rule. I cross J is plus K. I cross J is plus K. J cross K is plus I. And K cross I is plus J. This is called clock rule of cross multiplication. Okay, so I cross J is plus K. That means this minus sign will be there. Now next is I cross K. I cross K means we are going opposite side, so I cross K means minus J. that will be minus minus plus, so it will be 3 j cap. Okay, so V cross B is 2 into 10 to the power of 5 3 j cap minus 4 k cap. Okay, but now we have figured out the force, vector form of the force, 2 into 10 to the power of 5 into 3 I cap, 3 j cap minus 4 k cap. But if you see, they are asking the magnitude of the force. Now you have to find the magnitude of the force. So basically it will be 3.2 into 10 to the power of minus 14 into square root of, so magnitude of force is basically same as a vector, 3 square plus 4 square. Okay, when you are finding magnitude of a vector, let's say vector A is equal to Ax I cap, Ay j cap, Az k cap. So magnitude of vector A is given by square root of Ax square plus Bx square, sorry not Bx, X square plus Ay square plus Az square. Okay, sign does not matter because you are adding the square term, so plus minus sign does not matter. 3 square plus 4 square is 5. So 3.2 into 5 into 10 to the power of minus 14. So it will be 15, 15 plus 1, 16, almost 16 into 10 to the power of minus 14, or 1.6 into 10 to the power of minus 13. Okay, so 1.6 into 10 to the power of minus 13. Okay, little lengthy question but easy question, lengthy question but easy question. Okay, now next, a proton and alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular paths is. Okay, proton and alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. So we know that radii of rotation in a magnetic field is given by mv by qb. Okay, velocity for alpha particle and proton are same. Velocity for alpha particle and proton are same. Now charge of a proton is E and magnetic field is constant. What about alpha particle? Alpha particle has 4 times mass of proton but 2 times charge as proton as well. So now what is the ratio of proton and alpha particle? So order of ratio is always important. I am fed up telling that multiple times, but still you are making mistake in the exam. So this will be 2 times MPV by EB. Okay, so this is 2 times. So RP by R alpha is 1 by 2. It will be 1:2. RP by R alpha will be 1:2. Okay. Now next, a solenoid of length 50 centimeter having 100 turns carries a current of 2.5 ampere. The magnetic field at one end of the solenoid is. So solenoid has length is 50 centimeter and 100 turns, total number of turns is 100. Okay, current is 2.5 ampere. Okay, now what is the magnetic field at one end? Magnetic field at one end. Okay, sorry, pole is not available to the person who does the pole is not here today. Okay, D is the answer. Let's see. So magnetic field at the center of a solenoid is given by, magnetic field at the center of a solenoid is given by mu naught Ni. Okay, and at edges, if you are being asked at one end, it will be mu naught Ni, half of that. Okay, because at the edges what happens, the magnetic field drops to half, but at the center it is uniform. But if you come exactly at the end, the magnetic field drops to half. Okay, now obviously if you see, number of turns per unit length here is 100 divided by 0.5, that is 200. Why? Because the length is 50 centimeter, 50 centimeter means 0.5. Okay, total number of turns is 100, so number of turns per unit length is total number of turns divided by the length, that is 0.5. Here it will be 200. Now let's put the value. 4 pi into 10 to the power of minus 7. Mu naught is 4 pi into 10 to the power of minus 7. N is 200. Current is 2.5 and whole thing is divided by 2. Okay, you can cancel this and get 100 over here. Now let's simplify. 4 into 2.5 is 10. Okay, 10 into, there is 100, and then we have a pi, and we have a 10 to the power of minus 7. So it will be 1, 2, 3 zeros. So pi into 10 to the power of minus 4. So 3.14 into 10 to the power of minus 4. Okay, so it will be 3.14 into 10 to the power of minus 4. So option D is not correct. Option B is correct, because in the question one end of the solenoid is mentioned. Because one end of the solenoid is mentioned, you have to multiply it with a factor half. If it is said at the center of the solenoid, then option D would be the correct answer. Okay, now next. My microphone's volume is maximum. Okay, you check once. Now I'll try a little bit more, but my microphone's volume is maximum. You check your device volume. If that does not work, you can do one thing. You can log in from YouTube from your web browser. Okay, even in your mobile phone, use web browser and check. Okay, web browser generally gives a better sound quality. This question: a straight wire of length 50 centimeter carrying a current of 2.5 ampere is suspended in mid-air by a uniform magnetic field. Okay, of 0.5 Tesla. The mass of the wire is, so a wire basically is suspended in a magnetic field. Okay, so straight wire, current is being carried through this. So this is the weight of the wire and this is the force on the wire due to magnetic field. So what is the force on the wire due to a magnetic field? Magnetic force on a current carrying wire is BIL sin theta. Here sin theta is 1, so only BIL, and that should be equals to mg. Okay, so BIL and mg, they are balancing each other, so mass will be BIL by G. BIL by G. B is 0.5 Tesla, current is 2.5. Okay, the length is 50 centimeter, so centimeter to meter you have to convert, divided by G is 10. Okay, you are trying to find mass, 0 0 cancels and you get 1.25 in 2.5, 6.25 into 10 to the power of minus 2. 6.25 into 10 to the power of minus 2, or 62.5 into 10 to the power of minus 3. everything is in SI unit, so answer is also in SI unit. So this is in kilograms, so this will be 62.5 grams. Okay, this will be 62.5 grams. Okay, now remember how I multiplied it. I will teach you a trick. So 0.5 basically represents half. 0.5 multiplying by a number with 0.5 basically represents multiplying by half, which is much easier to understand. So 0.5 into 5 is 2.5. 0.5 into 5 is 2.5. So 2.5 into 2.5 is 25 into 25 is 625. So 2.5 into 2.5 is 6.25. Okay, so there will be 625 two decimals. Now you just rearrange it, find the corresponding value in grams, and that's it. Next, the magnetic field at the center of a current carrying loop of radius 0.1 meter is 5√5 times that at a point along its axis, the distance between the points. So here magnetic field at the center, magnetic field at a distance. Okay, at a distance x. So radius suppose is r. Then we know that magnetic field at the center, it is 5√5 times magnetic field at a distance x. What is the formula for magnetic field at the center? Mu naught by 2 I by r. What is the magnetic field at a distance? Now 5√5 is basically 5√5 can be written as √5 cube. Okay, or 5 to the power 3 by 2. Okay, so let me write that. So this is 5 to the power 3 by 2 into b at a distance. We have done the derivation multiple times during our PU class. Mu naught by 2 I r square divided by r square plus x square to the power 3 by 2. So obviously mu naught by 2 cancels, I cancels. Now do the cross multiplication, we get r square plus x square to the power 3 by 2 equals to 5 to the power 3 by 2 into r cube. Okay, now take cube root of both side. If you take cube root of both side, you get r square plus x square to the power half equals to 5 to the power half into r. Right, all the cubes are gone. Now square both side, r square plus x square equals to 5r square. Obviously 5 half whole square is 5 and r whole square is r square. Now simplify, you get x square equals to 5r square minus r square, that is 4r square. So x equals to 2r. Okay, x equals to 2r. So r here is given as 0.1. So 2 into 0.1, that is 0.2 meter. So this is 0.2 meter. So whenever you see a question where a formula heavy question, okay, put the values at the end. Put the value of r or distance or charge etc. at the end as much as possible. Okay, that will save you a lot of time. I used this value, but I have not using r value from the beginning, because we know that eventually the distance x will come in terms of r only. Okay, now next question. A convex lens of focal length 20 centimeter, figure A, is cut into two equal parts so as to obtain two plano-convex lens as shown in the figure B. Two parts are then put into contact as shown in the figure C. What is the focal length of combination C? So here a plane convex lens, it is cut from here, made into two parts. Now they are inverted and joined like this. Okay, it will not behave as a concave lens, it will still behave as a convex lens. I discussed a little bit about it yesterday. So this will still behave as a convex lens, and because when you cut a lens along its diameter, it becomes, focal length becomes 2f. This will also be 2f, and if you join them, so the equivalent focal length will still again be f. Okay, if you join them back, no matter how you join them, in inverse order or direct order, focal length will not change. Focal length will remain same. So focal length initially was 20 centimeter, focal length finally will also be 20 centimeter. Okay, it does not change on if you cut it and rejoin it. But last year there was a question where first it is cut like this, then it is cut like that. Just remember, if you cut it along the diameter, focal length becomes twice, power becomes half. But if you cut it along the principal axis, neither power nor focal length, nothing happens, nothing changes. Okay, everything remains same. Now let's move on to the next question. The power of an equiconcave lens is minus 4.5 D and is made of a material of refractive index 1.6. The radii of curvature of the lens is. So power is given minus 4.5 D. Power is equals to what? Power equals to 1 by focal length. Okay, it's a equiconcave lens. Equiconcave lens means this is equiconcave lens. This side the radius of curvature is negative, this side radius of curvature is positive. So R1 is negative, R2 is positive. Okay, R1 is obviously equals to R2, but anyway, that should be equals to N minus 1, 1 by R1 minus 1 by R2. This is the formula, lens maker's formula. Okay, now 1 by F directly is given minus 4.5. So minus 4.5. Now remember, when we are solving it, the answer will be in meters. Answer will be in meters, because if power is given, that means focal length and all the distances are measured in meters only. Diopter is SI unit. So now refractive index is 1.6 minus 1. What about 1 by R1 minus 1 by R2? So as I mentioned, R1 is negative, so it will be 1 by minus R minus 1 by R. Okay, R2 is positive, so both of them are equals to R, right? So we are trying to find that. So that means 0.6 into minus 2 by R. So the minus sign cancels. Next, R value is equals to 0.6 into 2 divided by 4.5, and this is in meters. Okay, this is in meters. So decimal gone, 3 2s are 6, 3 15s are 45, so we get 4 by 15 meters. Now to convert it into centimeter, we have to multiply by 100. 5 3s are 15, 5 20s are 100, so it will be 80 by 3. 80 by 3 means 3 2s are 6, 3 2s are 6, almost 27 centimeter. Now if you see that, so only one option is given, which is this. Now as I mentioned, radii of curvature both will not be negative, one will be negative, one will be positive. But in this option only negative is given, so you will choose the negative one only. But remember that one of the radii of curvature will be negative, right? The first one will be negative, the second one will be positive, because radii of curvature also have sign. So if this is the lens, this side is on this side. Okay, this is the positive x-axis, this is the negative x-axis. So any distances along negative x-axis is negative. Concave lens focal length will be negative. Yes, focal length will be negative. Focal length is given negative only. Power is given negative. Arshia, don't worry about dress code. Okay, don't think too much about dress code. So you are allowed in normal dress, okay, and no jewelry and no watch, no if you are wearing specs etc., then it is allowed. No artificial things like sunglasses etc. are not allowed, and you can go by normal chappal. You are not allowed to wear a shoe or like that, and proper dress, okay. It should not be too casual, it should not be too formal. Normal standard dress by which you have appeared for your college exam, you can go by that uniform as well. Bharti Reddy, if you are watching from the beginning, you can score 30 plus. If the refractive index from air to glass is 3/2 and that from air to water is 4/3, the ratio of focal lengths of glass lens in water and in air is. So focal length in air is given by 3/2 minus 1 into 2/r. Okay, so that is half into 2/r. Now focal length in water, when the lens is immersed in water. So basically the question is asking, you have a lens, first case is air, now second case the same lens is put into water, okay, water. Suppose this is FA, this is FW, then what is the ratio of FA by FW by FA? Okay, you have to find FW by FA. Make sure you read the question carefully. Water by air. Okay, so that will be, and what formula we will be using? 1/f equals to n minus 1 2/r. Okay, this is the common formula, lens maker's formula that we are using. So now it will be 3/2. When it is in water, you have to divide this n by the refractive index of the surrounding medium. For air, surrounding medium is 1. Okay, and for water it is 4/3. Okay, so you have to divide this by 4/3 minus 1 into 2/r. 2/r will cancel, so it does not matter. So it will be 9/8 minus 1. So if you simplify this, you will get 9/8 minus 1. So it will be 1/8 into 2/r. Now let's find out. So let's take this one first, then divide it by FW, because eventually we want to find FW by FA. So if we divide 1/FA divided by 1/FW, we get FW by FA, and that is equals to half divided by 1/8, or FW by FA equals to 8/2, that is 4. Okay, so it will be 4:1. Remember, when you immerse a lens into water or any other medium other than air, the focal length always increases. Okay, focal length always increases if you immerse it into a liquid. Okay, option D is correct, not C. So read, water to air, water to air. Here whatever you are getting is basically inverted. So if you want to directly solve it, so you calculate FA from here, so that will be equals to R, and if from here you calculate FW, which will be 4R. Now you divide. Okay, if you are confused how I have done it, you don't need to go by this way, you can do by your own way. So it is 1/FA, so FA is R. This is 1/FW, so FW is 4R. So FW by FA is 4R by R, that is 4:1. So 4:1 is correct. Okay, make sure always, I multiple time to tell you that whenever a ratio based question is asked, read the order of the ratio. Still you are making mistakes. I hope you will not repeat that in the exam tomorrow. A plain glass plate is placed over a various colored letters, violet, green, yellow, red. the letter which appears to raise more. So here we have a glass slab, violet, yellow, green, red, etc. are placed over here. So any color based question, you need to consider two colors only, remaining colors are just distraction. What are those two colors? Violet and red. Sometimes instead of violet, blue is given. Blue and violet are cousin brothers which are very close to each other. Okay, so violet and blues can be given, otherwise violet and red or blue or red. If violet and blue both are given, only violet and red. Okay, blue, if violet is not given, blue, if violet is given, violet and red. Okay, so just these two colors you need to consider for answering. Now when the ray of light tries to travel from here, one ray will travel like this, another ray will travel like this, and this is the rays. Rays means how further from the bottom it appears. You use the same experiment to measure the refractive index of glass material. Okay, now here this raising happens because of the refractive index. For different colors the refractive index is different. Okay, for different colors refractive index are different, and refractive index is inversely proportional to wavelength. Refractive index is inversely proportional to wavelength. Higher the wavelength, okay, smaller is refractive index. Smaller the refractive index, the rising becomes small. Okay, smaller the refractive index, the rising becomes small. Okay, so from here we can say that because the violet has a wavelength of, so lambda V is about 400 nanometer and lambda red is 700 nanometer. So definitely the wavelength of red light is more. That means wavelength, the refractive index of red is less than that of violet. Refractive index of red is always less than that of violet. So in this particular case, violet will rise more compared to red. Okay, violet will rise more compared to red. So for this question, correct answer is violet. So only two colors you need to consider, and you should remember this. If you remember this, based on the question to question, the answer might vary, but concept will be same. The red color has a smaller refractive index compared to violet color. If epsilon naught and mu naught are permittivity and permeability of free space, and epsilon and mu are corresponding quantities for a medium, then refractive index of the medium is. So this question combines electromagnetic wave and law of refraction. We know that refractive index of a medium or relative refractive index of a medium is given by speed of light in vacuum divided by speed of light in that particular medium. Okay, this is always. Now speed of light in vacuum from EM wave chapter, we know that that is 1 by square root of epsilon naught mu naught. By going by the same logic, we can say that speed of light for a given medium should be epsilon mu. Okay, 1 by. Now if you put that values over here, you get, because this is division of division, this will go up, so you get mu epsilon divided by mu naught epsilon naught. Okay, this is 1 by, so that why it is coming in the division. This is 1 by, so it will, division of division goes to be multiplication. Now one more important thing, this entire thing can be written as mu r epsilon r. What is mu r? Mu r is called relative permeability, okay, which is mu by mu naught, and epsilon r is relative permittivity, which is epsilon by epsilon naught. Okay, so if you see a question where instead of giving all these they have given this, you should remember this is correct. Okay, in terms of relative permeability, this is correct. So correct answer for this question is option A. Okay, now let's move on. In Young's double slit experiment, two wavelengths lambda equals to 780 nanometer and lambda 2 equals to 520 nanometer are used to obtain interference fringes. The nth bright band due to lambda 1 coincides with n plus 1th bright band due to lambda 2, then the value of. So n lambda 1 is basically n plus 1 lambda 2. Okay, this is the simplest formula. Nth bright band due to lambda 1, n lambda 1, n plus 1th bright band due to lambda 2 is n plus 1 lambda 2. Okay, so you just need to use this equation and simplify. Lambda 1 is 780, so n into 780 equals to n plus 1 into 520. 0, 0 cancels, 26, 39, 13, 2. Oh, sorry, not 13, 3. 3 13s are 39. So you get 3n equals to 2 into n plus 1. That is 3n equals to 2n plus 2. So n equals to 2. N equals to 2. So n equals to 2 is the correct answer for this question. So easy question, don't make it complicated. As I always say, two Polaroids P1 and P2 are placed with their axis perpendicular to each other. So P1 and P2 are placed their axis perpendicular to each other. Okay, unpolarized light I0 incident on P1. So unpolarized light I0 incident on P1. A third Polaroid P3 is kept in between P1 and P2 such that its axis makes an angle 45 degrees with that of the intensity of transmitted light through P2 is. So here we have kept another Polaroid which is making an angle 45 degrees with this one. Okay, now this will also make an angle 45 degree with this one because the angle between these two is 90. So the angle between these two will also be, if this is 45, this will also be 45. Now how to solve such question? This is one of the very typical question of KCET. Okay, so first step number 1. When unpolarized light falls on a Polaroid, the intensity becomes half and the light becomes polarized. Okay, the light becomes polarized. Okay, once light is polarized, you can start applying Malus law. If the light is unpolarized, you cannot apply Malus law. Malus law is only applicable when the light is polarized. So this intensity which is coming from here is I0 by 2. Now this angle is 45 degree mentioned in the question. So the intensity of light which is coming out from this Polaroid, say I3. This is Polaroid 3, right? So this, let's say this is I3. So what is I3? I3 is equal to I0 by 2 cos square 45 degrees. Okay, so I3 equals to I0 by 2. I0 is by 2 is the incident light on this polarizer. So it will be I0 by 2 cos square 45 degrees. So I0 by 2 into half. Cos 45 1 by root 2, cos square 45 is half. So it will be I0 by 4. So I0 by 4 is falling on the third Polaroid. So I0 by 4 is falling on the third Polaroid. So final intensity will be I0 by 4. And what is the angle between these two Polaroid? Only angle between two adjacent Polaroid matters. Angle between two adjacent Polaroid matters. So it will be cos square 45 degrees again, because this is 90. Okay, this is 45. So 90 minus 45, this will also be 45. So it is again I0 by 4 into half, that is I naught by 8. Now how quickly you can simplify that? That gives you an advantage. Who says A? Option B is correct, bro. Bijay Sutakti, Suhail Mohammed. A is wrong. Okay. If in Young's double slit experiment using monochromatic light of wavelength lambda, the intensity of the light at a point on the screen where path difference lambda is k unit. The intensity of light at a point where path difference is lambda by 3. Very interesting question. So intensity of light in Young's double slit experiment is given by 4 I naught cos square phi by 2. Here phi is phase difference. But in the question phase difference is not given, they have given you path difference. So how to convert phase difference, how to find phase difference from path difference, which is given by 2 pi by lambda into path difference. Phase difference is 2 pi by lambda into path difference. So path difference for the first case is lambda. So what is phase difference? Phase difference is 2 pi by lambda into lambda, which is 2 pi. Okay, cos 2 pi is basically cos 0, so that is 0. Okay, or basically cos square phi by 2, sorry, my mistake. So I equals to 4 I naught cos square 2 pi by 2, that is 4 I naught cos square pi. Cos pi is 1. Cos pi is minus 1. Cos square pi is minus 1 whole square, that is plus. Intensity cannot be negative, so it will be 4 I naught. So intensity at x equals to lambda is 4 I naught, and this is given as k in the question. This is given as k in the question. Next they asking you what is the intensity of light at lambda by 3. So here the phase difference will be 2 pi by lambda into lambda by 3. So this is the second position. For second position this is lambda by 3, so lambda cancels and you get 2 pi by 3. Okay, now what is the intensity there? Intensity here will be 4 I naught cos square 2 pi by 3 into half. There is a division by 2, so this 2 cancels and you get 4 I naught cos square pi by 3. Cos square pi by 3 means cos 60. Cos 60 means half. Cos 60 means half. So 4 I naught half square, that is 4 I naught into 1 by 4. So that is I naught. Okay, so what is the relationship between k and this value? This is nothing but k by 4. Okay, so if you find here I naught equals to k by 4, and we have found the answer here as I naught, so it will be k by 4. So in KCET not all questions are straightforward and very simple. You have to do mathematics. There will be some lengthy question. You have to save some time for these lengthy questions. So I put you in timeout. You guys are coming back from different accounts. We place the thin transparent glass slab in front of both slit instead of just one. Will the central fringe will still be center or it? No. If you place a thin slit only at one instead of one, if you place it at both places, the central position will not change, and the only one single slit to measure the thickness of the plate, that portion is deleted. So if to trick you, if they say that okay, I put thickness on both plates, if the thicknesses are same, okay, if the thicknesses are same, then central maximum will still be at the center only. And if you say only one is there, how much by how much distance the central brightness will shift, that portion is deleted. That portion is not there. Maybe in JEE it might come, but in KCET that will not come. Okay, fix. What is that? Mahantesh, I told you 25, more than 25 you can score if you go through the entire lecture, right? Ending time, another 15 minutes. Okay, another 15 minutes. By 1 o'clock I will close. A plane wavefront of wavelength. So I will be solving up to 40 questions. Okay, 40 questions I will be solving. There are 10 more questions here. Okay, those 10 questions, take it as practice. Take them as practice and try to answer those 10 questions. Last 10 questions, you will be getting the PDF from the Rank Booster series PDF link already shared in our channel, in our WhatsApp channel. So if you are not joining our WhatsApp channel, do join our WhatsApp channel. There you will get the link to download the PDF. Go there, find today's lecture, 50 plus questions. 50 plus question revision, that is the name of this file. So download this and solve the last 10 questions. Previous 40 already 50 questions have already solved. Okay, I don't think go by the number because there are a lot of questions at the beginning without the numbers. Okay, so last 10 questions I will give you as homework. Not homework, that is just for your practice. You practice those questions and get your confidence back. Okay, so 40th question up to we will solve. A plane wavefront of wavelength lambda is incident on a single slit of width A, the angular width of the principal maximum. So here we have a single slit. Here we have the single slit diffraction pattern. Single slit diffraction pattern, which looks like this. This is the single slit diffraction pattern. So angular width means this is called angular width of the maximum. So if this is the width of the slit, which is A, if this angle is theta, okay, then this is given by A theta, okay, and A theta equals to lambda. So theta equals to lambda by A, but that is only half width. This is called half width. Okay, now this half width but in the question they are asking you angular width. This is the total angular width. So angular width is actually 2 theta, which is 2 lambda upon A. Okay, it is 2 lambda upon A. Okay, so this width is called half width, this width called full width. Okay, A theta equals to lambda for central maximum. Okay, other maximums theory are not there, only central maximum theory is there. So A theta equals to lambda and theta will be lambda by A. So from there you can calculate the full angular width. In Young's double slit experiment, the source is white light, one slit is covered with red filter, other with blue filter, thus there shall be. Okay, boys crazy, no, poll is not there today because the person who is doing poll is not available. There shall be alternate and red blue fringes, alternate dark and pink fringes, alternate dark and yellow fringes, no interference. So light is neither in monochromatic nor of the same frequency, so there will be no interference. There is a only exception is that if you are using white light. White light is a mixture of wavelength, so so even though that is not monochromatic, if you are using a mixture of light, okay, like white light, central bright fringe will be white. Okay, if you are using white light, central fringe will be white. You will get some colored fringes, okay, some random colors fringes, and then everything will be white again. This is only for white light. If you use two distinct wavelengths, interference will not happen. Red, blue, green, red, okay, yellow, green, yellow, blue. So in those cases you will not get any interference because wavelengths are completely different. White is an exception because it is not a separate wavelength, it's a mixture of color. Okay, that's why white is different. A 60 watt source emit monochromatic light of wavelength 662.5 nanometer. The number of photons emitted per second is, power of the source is given, okay, and wavelength of light is given. So from power, how to calculate energy? Energy is power into time, okay. So energy is power into time. So 60 watt means 60 joules per second, and here they have given per second, so multiply by second. So the energy is basically 60 joules. So energy is given 60 joules. Wavelength here is given 662.5 nanometer. We know that energy of a single photon is h into nu, okay, which is hc by lambda. Wavelength is given hc by lambda. Now you do not go to the electron volt route, because if you go by electron volt route, you again have to come back to joules, because the energy here given is in joules. So better use the h value itself. H is 6.62 into 10 to the power of minus 34. C is 3 into 10 to the power of 8, and lambda is 662.5 into 10 to the power of minus 9. Or you can cancel these two quantities and you can write 100 over here, okay. So now basically you have to find the energy of a single photon. This is one photon only. So 3 into 10 to the power of 34 minus 34 plus 8 is 26, minus 26 plus 7 is minus 19. Okay, so this is the energy of a single photon. So how much photons required? Suppose we require n number of such photon emission. So the total energy becomes n into E1, which is n is n is E by E1. E is 60 joules. So 60 divided by 3 into 10 to the power of minus 19. So it cancels, you get 20. So 2 into 10 to the power of 20. Okay, it will be 2 into 10 to the power of 20. Okay, so calculate the energy of single photon, calculate the energy that is required, then energy required divided by energy of a single photon to calculate the total number of photons. Next question, a particle is dropped from a height capital H. The de Broglie wavelength of the particle depends on height as. So when you are dropping a particle from some height h, at the bottom how the de Broglie wavelength depends. Very interesting question. We know that de Broglie wavelength is given by h by p. This is Planck's constant. This h is height. Okay, don't confuse between them. Now basically you have to find the momentum of the particle, and then you can say how the wavelength changes. Okay, so wavelength is proportional to the momentum. Now you have to basically calculate momentum. How to calculate momentum? At the top position, the entire energy of the object is potential energy. At the bottom, entire energy is half mv square. Okay, so from here kinetic energy we can write this kinetic energy half mv square should be equals to mgh. Okay, now so kinetic energy, entire kinetic energy, potential energy at the beginning is getting converted into entire kinetic energy, right? So conservation of energy. Now mv square we are not interested, we only find what is kinetic energy, that is mgh. Now momentum is given by square root of 2mk. Momentum is given by, momentum for a particle is given by square root of 2mk. So from here we can say that, so momentum is square root of 2mk. So momentum is basically proportional to square root of h. right? If you put the H value over here, mg are constant, does not matter, so you will get m2mk into mgh. So these are all constant, only thing that we are interested in this H. So momentum is proportional to square root of H, so lambda should be proportional to 1 by square root of H, or lambda should be proportional to H to the power minus half. So lambda should be proportional to H to the power of minus half. Not an easy question, but again not a super difficult question. So your conservation of energy and momentum and then de Broglie balloon all are linked. Okay guys, so the remaining 10 questions you will find it over here. Try to solve them one by one. This question also I have solved in my lecture yesterday. You can check some of the questions that I have solved. Okay. Now and if you still have any doubts, you can mention in the comment section of this lecture. Once the lecture is stopped, you will be able to comment on it, comment on the lecture, and don't forget to download the PDF will be available in our WhatsApp channel, right? See you tomorrow morning at 6:30 AM. I'll be coming live. I will be taking very short quick revision of all few more questions. Obviously quick revision means not theory revision last moment, no point in discussing theory. Maybe I will discuss some important chapters, formulas, and some questions. Okay, so tomorrow morning 6:30 AM I will come back with another live. Till then, bye. Okay, next there is a 2 PM there is chemistry live, because you have chemistry exam also tomorrow. So chemistry live, Ekta ma'am will come for at 2 PM. So go have your lunch and then come back for chemistry class. Okay, see you, bye.